Bones, we're back again. How's it going, everybody? Good morning. Okay, so we've been talking about the atmosphere, okay? And we're building up towards being able to figure out how the atmosphere causes our weather and all of that kind of stuff. But before we get there, we have to figure out where the atmosphere came from. Because earlier in one of our lectures, we learned that the atmosphere has not been here as long as the Earth. The Earth has been here for 4.6 billion years. Our atmosphere has only been here for about 800 million years. So where did it come from? What's its origin? What's it doing? Okay, we've learned about what it does for us. It protects us. It supports life. It maintains heat. But where did this atmosphere come from? Well, this is what today is about. So here we go. Ready, Bones? All right. Our early atmosphere looked nothing like it does today. We learned that our atmosphere today is composed of 78% nitrogen, 21% oxygen, and 1% a little bit of everything else: water vapor, carbon dioxide, other types of trace gases. So what did our early atmosphere look like? Well, first of all, our early atmosphere had none of that. Our early atmosphere had no oxygen, none. No oxygen means no people, okay? No bones, no animals, all right? It had no water vapor, no water, no people, no animals, no plants, no bones. And it had no ozone, no protection from the sun. We can't be protected from the sun. No people, no bones, no animals, no plants, no nothing. So our first atmosphere wasn't very good at supporting, being able to support life. So what was in it? Methane gas, bad, poison. Ammonia, good to clean with, bad to breathe, bad, poison. Carbon dioxide, bad, can't use it, carbon dioxide. So that was it. Methane, ammonia, carbon dioxide. Not good for us, not good for us, not good for us. All three. So we were in here. All right. Now, eventually that changes over, which is good for us, which is why we're here. And what happened was there was a lot of instability in our atmosphere. Okay. It was very unstable because there was no ozone layer, because there was no set atmosphere. The Earth was getting pegged with meteors and things from outer space all over the place. Okay, so what happened was outgassing from volcanoes released water vapor and carbon dioxide and nitrogen from the Earth. Okay, so there were volcanoes even back then. There was liquid hot magma and lava coming up. If you can picture this, picture the Earth as this big rock with volcanoes that were erupting and getting hit with meteor impacts that caused holes in the Earth's surface like Swiss cheese, which caused more eruptions and gases to come out. If you've ever seen Star Wars Episode 3, The Fire Planet, it kind of looked like that. It was a pretty scary place. But by the volcanoes and the outgassing and the eruption of volcanoes from this early Earth as we knew it, we started to get the new atmosphere because water vapor started to be released into the atmosphere, because nitrogen started to be released into the atmosphere. And with the meteors hitting it, all of this stuff started to happen. So what started to happen, and how did we end up with the atmosphere that we have today? Well, what happened was, because the Earth was being hit with meteors, because the Earth was erupting with huge and out of control volcanoes, okay, the Earth started to cool. Okay, the Earth started to be covered with these gases, and it didn't allow as much sunlight and ultraviolet radiation to reach the surface of the Earth. So the Earth started to cool. Now, with the volcanoes being released and with meteors hitting the Earth and with the outgassing that was happening, remember I said water vapor, okay? Water in the form of gas was released into the atmosphere, okay, around the Earth. Well, when water cools, that gas turns into water, okay? Water vapor turns into water liquid, and it started to rain, and it rained a lot. It rained so much that the oceans were formed, okay? And this is because all of those gases from the eruptions blocked out the Earth's sunlight and caused the Earth to be able to cool down a little bit. So now, the ocean waters help to remove the carbon dioxide from the atmosphere. Remember, too much carbon dioxide in the atmosphere means too warm, still too warm. And what they started to find was, scientists believe, that they started to find algae in these newly formed oceans. And it rained for millions of years. Like I said, it takes millions of years of rain in order to get enough water to form our oceans. And what happens was they started to find, they believe they found green plants or algae, okay, in the water. Now, algae is a green plant that undergoes photosynthesis, okay? Photosynthesis takes carbon dioxide out of the atmosphere and changes it into oxygen. That's important. That still happens today, okay? We use the trees and the plants and the grass outside. They take the carbon dioxide that our bodies produce and it changes it into oxygen for us to be able to breathe. Well, this started to happen in the oceans. There was a large amount of algae, and they all started to undergo the process of photosynthesis, which took the carbon dioxide out of the atmosphere and changed it into oxygen. This allowed the ozone layer to form, okay? Once the oxygen was available, the ozone layer was able to form, which further helped block ultraviolet radiation. Remember, we talked about the ozone layer in a previous video. The ozone layer is located in the stratosphere. It's a form of oxygen. So once the ozone layer was able to form, it blocked out further heat and ultraviolet radiation from the sun, which allowed the Earth to cool even more in order to get the atmosphere that we have today, which is, remember, is 78% nitrogen, 21% oxygen, 1% a little bit of everything else. So to recap, basically what happened? Volcanoes and meteors, volcanoes started to erupt from the early Earth. Meteors were hitting the Earth, plugging holes in it. All of these gases were being released. Water vapor was being released and caused this big cloud cover, which caused the Earth to cool. When the Earth cooled, that water vapor started to rain, and the rain rained so much that the oceans were formed. In the oceans, we find algae. Algae are the little green plants that undergo photosynthesis, which further takes carbon dioxide and changes it into oxygen, which helped form the ozone layer, and then the oxygen remained around for life and for us to be able to start breathing, okay, with early forms of life. So the original atmosphere was nothing like you saw today. The original atmosphere, remember, was poison. And it took the volcanic eruptions and the raining for millions of years and the oceans to form and the algae to undergo photosynthesis in order for us to get a nice balance of gases in order to support life as we know it today. So that's where the atmosphere came from. Now, we've talked about functions in the greenhouse effect already and how it helps. What are some problems that we're finding in the atmosphere now? One of the big problems that we find in our atmosphere is that we can prevent is pollution, whether it's by nature or human activity. Now, nature, there's nothing we can do about it. If a volcano erupts now, there's nothing we can do about it, but it has very minimal effects on the atmosphere. Human activity is the big one. The burning of extra fossil fuels, the pollution in our oceans, the deforestation of our forests. Okay, that's where the bigger problems are happening with our atmosphere, and it's causing our atmosphere to become more unstable. It's causing holes in the ozone layer to form, which is allowing extra radiation to come into the Earth, which is causing the greenhouse effect, which we've talked about. Okay, so pollution is a big problem in the atmosphere that we can prevent. By moving to more towards green technologies that we now have available to us. In the past, we didn't know what burning fossil fuels was doing to our atmosphere. When we first started to industrialize and use technology, but now we do, and so now it's the big fight to start to transition from the burning of fossil fuels into the use of green technologies going forward. So, what are some effects of pollution? All right, it changes our weather patterns. Okay, we're getting something called global warming. Global warming is a real thing, and global warming doesn't mean the entire world is getting warm at once. Global warming means slowly but surely the overall warmth of the Earth is increasing, but it promotes bigger storms when they happen. It promotes more drought. So we go through more periods where there is no storms, and then when the storms hit, they are bigger and stronger and more dangerous than ever before. So you'll get more temperature ranges. The cold won't just be a little cold; it will be really, really, really cold. The warm won't just be a little warm; it'll be really, really, really hot. The hurricane won't be a little baby hurricane. It will be a huge, big hurricane. The blizzard won't just be a little blizzard. It will be a big, huge, destructive blizzard. So that is happening, and that's the effects of pollution. Climate is changing. Okay. Now, the climate is changing all over the world. Okay. Climate is the weather patterns in an area over a long period of time. Over a long period of time, things are generally warming up. That's causing living organisms to change their migration patterns. it's causing organisms that used to have to need the warmer weather, that had to live closer to the equator, to start moving northward to find new places to live, to find and bring the diseases with it. Here on Long Island, we used to never have to worry about mosquitoes and West Nile virus and things like that. And now, a lot of insects that used to live near the equator are starting to migrate north, and it's causing more competition for the organisms that are already living in our areas. The North and South Pole, because of the warming of the Earth, is making it more difficult for polar bears to exist. Polar bears are finding it more and more difficult to find food and to move around to their natural habitats. It's making it more difficult for penguins to exist, which affects food chains and ecosystems and all of that stuff. So pollution has a big effect on everything that's going on in the world, not only the weather, but the climate and how living organisms have to fight to survive. And a lot of this pollution is due to the burning of fossil fuels. Okay, it's very simple here. Burning fossil fuels adds carbon dioxide to the atmosphere. The more carbon dioxide in the atmosphere, okay, the more the temperature of the Earth goes up. All right. So burning fossil fuels adds carbon dioxide. Carbon dioxide causes global warming. All right. It's as simple as that. We do have the technologies now, so we do not have to burn as much fossil fuels. It's a matter of transitioning over to those new technologies that we have. Okay, you can smell the burning of fossil fuels in when you get dropped off on the bus in the morning in the parking lot. Okay, you can smell those exhaust fumes. We have the technology now not to put gas in cars. We just have to be able to make that transition slowly but surely in order to get everybody on the same page. So we stop burning as many fossil fuels to provide the products that we need on everyday life. Okay, because what this is all doing is it is destroying our ozone layer. Our ozone layer is being destroyed by these things called CFCs, chlorofluorocarbons. So there is a lot more restrictions on air conditioners and refrigerants, where they used to use CFCs to run, and now with new government regulations, you're not allowed to use some harmful chemicals that they used to use in certain products to keep your homes cool, to keep your refrigerator cool, and stuff like that. The ozone layer is also being destroyed by these things called bromides and nitrogen oxides. Okay, so just understand, in general, pollution is a big, huge, main problem of the atmosphere. It is affecting our weather patterns. It's causing climate change. It's affecting the competition and ecosystems of living organisms, and it's all caused by the burning of fossil fuels, which is destroying the ozone layer, which is causing all of these effects to happen. Okay. Okay.